Let's continue our lecture video in integral calculus, and this time the topic is exponential function. For the integral of e raised to u, then the derivative of du, the answer will be e raised to u plus c. Now for the integral of a, or that is a constant, so for the integral of a raised to u and then the derivative of u, the answer will have a raised to u all over ln u plus c. Now let's use this pattern in the following examples. Integrate the following and check by differentiation. Number 1, the integral of e raised to negative 3y dy. So the pattern that we're going to use is integral of e raised to u, derivative of u is equal to e raised to u plus c. Now if we follow this pattern here, if we let u is equal to negative 3y, the exponent, then derivative of u is negative 3 dy. And using the pattern, we have it as copy e raised to the u, which is negative 3y, and the du, so here is the du, that is negative 3 dy. And since there's no negative 3 in the given, therefore, we will balance it by putting negative 1/3 outside the integral sign. So discard this one. Then we have here negative 1/3. Then follow the pattern for the answer. So e raised to u plus c. So that is the answer. Now for checking by differentiation, let's differentiate or derive the answer, which is negative 1/3 e raised to negative 3y plus c. So that is equal to negative 1/3, and the derivative of e raised to negative 3y is e raised to negative 3y, then the derivative of the exponent, which is negative 3. Then the derivative of constant c is 0. So this is now equal to e raised to negative 3y. Since it is the same with the given, therefore this answer is correct. So that's for number 1. Let's go to number 2. We have here the integral of e raised to t minus e raised to t raised to the power of 2 dt. Now if we let u is equal to e raised to t minus e raised to negative t, wherein we are attempting to use the power formula, the du here is equal to e raised to t, then derivative of exponent, minus e raised to negative t, derivative of the exponent. So that is equal to e raised to t plus e raised to negative t. Then, using the pattern for power formula, we have it as the u, then raised to the exponent 2, then the du, which is e raised to t plus e raised to negative t, which is not equal to the, or it is not the same with the given. Therefore, the power formula is not going to be used. So how about if we try using the pattern here in exponential function? Well, we have a problem because there's a power of 2 here. So we might as well expand it first before we proceed to using this pattern. So expanding the e raised to t minus e raised to t times e raised to t minus e raised to negative t. So e raised to t times e raised to t, so that becomes e raised to negative positive 2t. E raised to t multiplied with e raised to negative t becomes negative e raised to 0, because the exponent e raised to the exponent t here is positive minus negative, so it becomes 0. How about negative e raised to t times e raised to t? That becomes negative e raised to 0 also. Then negative e raised to negative t, and then negative t multiplied with negative e raised to negative t, it becomes positive e raised to negative 2t. So this e raised to 2t. Note that e raised to 0 is equal to 1. So this is 1 plus 1. So that becomes negative 2 plus e raised to negative 2t. So let's use this. The expanded form, we have the integral of e raised to 2t minus 2 plus e raised to negative 2t dt. That is equal to integral of, let's distribute, this is integral of e raised to 2t dt minus 2 integral of dt plus integral of e raised to negative 2t dt. Then we can now use the pattern for e raised to u derivative of u. So if we let u here equal to 2t, therefore du is equal to dt. If we let u is equal to negative 2t here, du becomes negative 2 dt. So this is 2. Okay, then this one here becomes a power formula. So let's use the pattern. So integral of e raised to 2t 2 dt, and to balance, let's put 1/2 minus, this is 2 integral of e, or that is integral of t raised to 0 dt plus, this is integral of e raised to negative 2t times negative 2 dt. Then let's put a negative 1/2 outside the integral sign. So this now becomes negative, this is 1 over 2 e raised to 2t minus 2 t raised to 0 plus 1 all over 0 plus 1 minus 1/2 e raised to negative 2t plus c. Therefore, the answer here is 1/2 e raised to 2t minus 2t minus 1/2 e raised to negative 2t plus c. So that is now the answer. Now for checking, by differentiating, so we have here d over dt 1/2 e raised to 2t minus 2t minus 1/2 e raised to negative 2t plus c. So that is equal to 1/2 e raised to 2t, then the derivative of the exponent, which is equal to 2 minus 2 minus 1/2 e raised to negative 2t, derivative of the exponent, which is negative 2, plus derivative of constant c, which is 0. So this becomes e raised to 2t minus 2 minus 1/2, or that is plus 1/2 e raised to negative 2t. This is positive. We can cancel this one. So this is e raised to negative 2t. Okay? So this is the same with the given, the expanded form. Since it's the same, therefore this answer is correct. Now that's for number 2. Let's proceed with the number 3. The integral of y e raised to negative y squared dy. Again, let's try to use the pattern. If we let here the u as negative y squared, therefore du becomes negative 2y dy. So using this pattern again, we can have it as integral of e raised to negative y squared, then the du is negative 2y dy. Now to balance, so that it will become similar with the given, we need to put negative 1/2 outside the integral sign. Then the final answer now here is negative 1/2, the pattern, the e raised to negative y squared plus c. So that is the answer for number 3. Now checking by differentiation, derivative of the answer negative 1/2 e raised to y squared plus c, that is equal to negative 1/2 e raised to y squared, then the derivative of the exponent is negative 2y plus derivative of c is 0, so that is equal to ye raised to negative y squared, similar with the given. Therefore this is correct. So that is for number 3. Here is number 4. The integral of v e raised to 3v squared minus 1. Again, here is the pattern, and let's try to use what we did with example number 3. Let u is equal to 3v squared minus 1, du is equal to 6v dv. Then use the pattern here. So we have here integral of e raised to 3v squared minus 1, and du here is 6v dv. Then put 1/6 outside the parentheses. So the final answer is 1/6. Then the pattern e raised to u plus c. So that is e raised to u, which is the 3v squared minus 1 plus c. So that is for number 4. Checking by differentiation, we have here the derivative of 1/6 e raised to 3v squared minus 1 plus c. So that is equal to 1 over 6 e raised to d power 3v squared minus 1. Then the derivative of u, or the exponent here, is 6v plus 0. That is equal to v e raised to 3v squared minus 1. So this is similar with the given again. Therefore, the answer for number 4 is correct. And last, number 5. For number 5, we have integral of 1 minus 2e raised to tangent x, then secant x squared dx. So, let's try to have u is equal to 1 minus 2e tangent x. So, if we satisfy here the formula, the pattern for the power, then we can solve it using the power formula. So du is equal to 0 minus 2e tangent x. Then what's the derivative of tangent x? We have it secant squared x dx. Therefore, du is negative 2e tangent x secant squared x dx. Substitute. We have the u, which is 1 minus 2e tangent x. Then we have the du, negative 2e tangent x secant squared x dx. So this is not similar with the given. Therefore, this is wrong. You cannot use it. You cannot use the power formula. So instead, let's try to look for another way of solving this. Let's distribute the secant squared x dx. So we have here integral of secant squared x dx. Then we have negative 2 e raised to tangent x. Then we have here secant squared x dx. If we let u here is equal to x, which is the angle, then du is equal to dx. Then this is a simple trigonometric formula. We will use simple trigonometric formula. What is the integral of secant squared x dx? So we have here secant squared x dx. Therefore, the answer here is tangent x. How about this one here? If we let u is equal to tangent x, then du, the derivative of u is secant squared x dx. We are actually doing this pattern here. So that is minus 2. Okay, so minus 2 integral of the e raised to the u, which is the tangent x, and then the du is secant squared x dx, and this is similar with this one. So since we were able to satisfy this pattern, therefore we will proceed with the pattern of the answer. That is negative 2 e raised to tangent x plus c. So that is the answer for number 5. Checking by differentiation, the derivative of tangent x minus 2e raised to the power of tangent x plus c. So that is equal to derivative of tangent x is secant squared x minus 2e raised to tangent x, then multiplied with the derivative of the power, which is, or derivative of the exponent. Derivative of tangent x is secant squared x plus c. Therefore, we have here 1 minus 2e raised to tangent x secant squared x. And this is similar with the given. Therefore, this answer here is correct. So that is for number 5.